All right, so we'll be building an application using Entity Framework Core. EF Core, the way that we're going to use it is still going to connect to a MySQL database. So I have MAMP started, and I also have MySQL Workbench up, so we can get a visual for what tables that we're looking at. And I'm just going to piggyback off of yesterday's demo of Trails, just because it's a single table and I can interact with it pretty easily. Cool. So let's see. What is this? I don't know. Okay, so terminal CD to my desktop. I'll use Candyman to create a project. Yo, Candyman EF demo. EF demo. Cool. Maybe I'll use some Bootstrap. Take some jQuery with it. Creates my projects. Here it is. So I'll open it up in VS Code. And I'll need a couple of new dependencies to get us started. And this will be one of them. This is going to be my Entity Framework Core. So we'll add that right there, save, when it'll prompt us to restore again. Yes, I want to build my assets, and yes, I want to restore. Cool. So our application is set up. Sorry, that's kind of small. Can everyone see? Cool, cool. All right. So to give you a brief overview of Entity Framework, with Dapper, we were writing raw SQL queries to query from our database, right? And whatever was brought back would map to objects that we have to find. Thus, that's our ORM, right? Entity Framework is a little bit different because it obscures a lot of that for us and handles the queries for us. So we don't actually have to write any SQL queries. What we're going to be doing is pulling back data sets from our database and using LINQ, which we all are familiar with at this point. Maybe we need a refresher for sure, but we'll be using LINQ to query from that data set that we pulled back from our database. Does that make sense? If it doesn't, it will become hopefully clearer in a minute. But yeah, we've loaded up our dependency. Next, we need to create a context file, and that context file, or that context class, is going to leverage Entity Framework Core to do that mapping for us. So whatever we pull back from our database, our context class will map those pieces into the objects that we're looking for. And I'll show you real quick. So we want to name these a little bit more descriptively. Is it a file? I always do that. Delete. I'll create a folder called models. In here, I'll create a file called EFDemo context. Cool. And it's better to make it more descriptive. Cool. And I have EFDemo context. My namespace, I think, was EFDemo.
Is that DB context? That's like you can't change the DB context.
This?
Right, yeah.
No, that's what you're inheriting from Entity Framework Core.
Oh, okay.
Yep.
Does it matter that your namespace is uppercase EF?
Was it?
Yeah.
I think
No, he made his namespace lowercase.
it's down. Oh yeah, that's one thing that Candyman will do for you when you start a project like this. I think I typed in EFDemo, right? Like this. It will downcase it for you. So my namespace is lowercase EF demo. If you want to change it, you can just change it to like a capital E and make sure that that's consistent across your application, though.
Right. Well, you had it capital E's.
Did I? Oh, this?
Yeah.
This is not. This has nothing to do with my namespace.
Got it.
Yeah, it's just another class name. But I can see what you're saying. Yeah, they're different. Cool. And eventually, what I'll be doing in this class is creating DB sets, which will go out and pull entire tables from my database for me to then shuffle through. But first of all, let's make sure that we're connected to our database, and then I'll show you how we can interact with those DB sets. Okay, cool. At this point, if you guys are going through this setting up process, once we've created our context file, we're going to want to add this line into our startup.cs, which will look very similar, or which will look very familiar to you if you guys have been using the, if you guys have been securing your connection with your SQL databases. So if you guys can see here, it's going to say refer back to the configuration tab in ASP.NET Core 2 so that we can go ahead and configure this application. So it's kind of like a pause here, go to this chapter, continue forward. When you're done with this chapter, come back here and add this line. Cool? So we'll just go ahead and do that. As we all know, in order for us to secure our database connection string, we need to store it in appsettings.json. And I think the name of my table was just called trails. Other than that, everything is good. And then I need... Sorry?
Are you 8889?
I am,
It
yes.
defaults to that.
Yeah, thank you. I will need this dependency so that I could extract that from my JSON file. Configure extensions, restore. Cool. And then I need this constructor function in my startup.cs here, which will require me to load up some using statements. Cool. And this is the line that we're going to replace with this line. So you know, so hopefully you guys know at this point that what this is doing is it's calling on that configuration object that we built here, and there's a .getSection method within that configuration object which goes into this JSON object and extracts whatever string that we're looking for. In this case, our DB info object. So, oh, that's the wrong one. So that's exactly what this is doing here. I'm going to add that as a service right here.
Do you have to replace that, or can you have both?
Sorry?
So can you have the, like, let's say you copied it from here, from the old one, and then you forgot to take it out. Can you have both without throw an issue?
I think it would, because it would be competing with each other at that point. Yeah. Couple of things that we do need to fix though is your typing of your context. We named it something different than this, right? So make sure you change this to EFDemo context, which means I need to use my models because that file is stored in my models. And this is tricky because this is going to require a use statement also, but for some reason the light bulb doesn't like to pick up on this dependency. It's always been that way. So it's right here. Just copy and paste this. Oh man, I missed it. And that will go away. All right, cool. So our entity framework core, or not our application rather, knows how to connect to our SQL database given our connection string now, right? It knows which database to look at, what the username is, what the password is, so it knows how to connect. Now we need to start interacting with our EF core ORM so that whatever data that we're pulling back from this database that we're connected to can map to some object that we've defined, right? In this case, the database that I'm connected to is trails, and I'm going to want to map all of these pieces that come back to trail objects. Does that make sense? Cool. So I have this that I created yesterday. I don't want to type all of this out, so I'm just going to copy and paste this. So this is my class that I have, right? Or my model, yeah. Or I guess they're the same, yeah. And I will create in my models a new file called trail. Oops. Close
the model view or the actual mapping of the database?
View models are 100% sole purposes for validations,
Okay.
and I'm not really doing like a validation demo. Even though these things, yeah, I mean, you guys get the picture though. There's a trail ID, there's a name, a description, trail length, elevation, longitude, latitude, created at, and that kind of maps to my database here. One thing that you might run into, EF Core, the data that you are bringing back from your database must map exactly to the attributes you've defined in your class. Does that make sense? I believe in Dapper, if there were fields in your database that were being brought back and there weren't those attributes listed in your model, it would just ignore those, right? Or if you had attributes listed in your model and you were bringing back data from your database that didn't map correctly to those values would just be left as null, right? So it would just be like, okay, I'm just going to map whatever you bring me back as best as I can. EF Core is going to be like, no, I need you to give me exactly what I need. No more, no less. If you do, I'm going to yell at you. Cool? Just keep that in mind. So you guys can see in this example here, the column names correspond exactly with the fields of my person class. Cool. And I think, did I forget anything? I have my namespace EFDemo here.
You take all that apart, right?
Yeah, I can just get rid of all of this just so you guys, it's a little bit easier to see. Cool. So what I'm going to do is create something called a DB set, which I believe is something defined in DB context that we bring in from EF Core. It would have to be. And this is where I define the mapping of what's coming back, right? So what model do I want my DB set or the data that I'm bringing back from my database to map to? Trail, right? So trail. And this is just the name that I give it, so that when I instantiate a new EFDemo context object, let's call it like underscore my context. I could do underscore my context dot users, and essentially what I've done is I pulled back that entire DB set. Cool. So you might want to name this something that makes sense semantically. So like trails, right?
Shouldn't this match the database table, or is that
The name here?
yeah?
Nope. This could just be X. This is a name that we're just giving the data set that we're bringing back. So I heard a couple of things like this should match the database. What do you guys mean? What should match the database?
The column, the table name should match.
The table name. No, that doesn't matter. Yeah.
So what is the difference between a DB set and a list? Why is this not a list of trails?
What this will bring back, it will be a list of trails. So you'll see when we call on EF, whatever instance of EF demo context that we have, dot trails. When we call on that, we'll need to store that in a variable, right? That variable will be typed as a list of trails. Cool. So we have this defined. So now I'm going to get rid of some of this stuff. We need this, we don't need that, we don't need this. Cool. So we have our controller, we have our model, and we have our context file here. So what should I do next from my controller so that I can start interacting with this context class? Instantiate it, yeah. Yeah, and I think, Reed, you were saying create a private variable to store that instantiated object into, right?
Yeah, and then,
Yeah.
and then fill it up with stuff.
Yeah. So I'll create a constructor function so that this happens when the controller gets created. I've called it home controller, so I need to rename this to home controller. My context name was called EFDemo context. I need to use my models. Cool. So in this private variable called underscore context, I'm going to store an instance of my EFDemo object. Does that make sense? Cool, cool, cool. So now, from my indexed method, if I can call on context dot, let me see, what did I call it? Trails? Oops. Trails. Dot trails. Is it a method? No, it's not a method. ef.trails. I could do this, but only assignment call, increment, new object expressions can only be used as a statement. So what this is saying is it needs to be stored in some type of list, like I think Scott was saying. Was it Scott?
Yeah, sure.
List of trail objects called my trails equals this. But again, if it's going to be in the list format, I need to list it, which means that I need links.
So why didn't you just set that up as a list to begin with, so that you don't have to list this? Why is it this DB set?
Because what it's bringing back is not going to be exactly in the form of like your system's list object. What this DB set is going to bring back, let me see here. Because this DB set is a method, not a method, a type of your DB context class that's being brought in through Entity Framework Core. So we need to call on DB set. If we just try to type it as list, this doesn't really know how to interact with your EF core, right?
So DB set is something specific to
Exactly. Yeah. Yeah. It's not. Yeah. Exactly.
Where's in your MySQL workbench? You have your trails. What's the table name called?
Trails.
With capital T.
Lowercase. Capital T. I think this is weird. My schema's name is lowercase t, but my table name is capital T.
Okay.
But I don't think it really matters.
If it doesn't, can we change it?
Yeah, I don't think it matters. Cool. So let's query for this. Let me check out my trails here. Cool, and I'll run it through my debug. Cool. It's gonna load up my page. Exception thrown. Something's wrong. Unknown column create at. Did I do that wrong? This says create at, so I need a D because there's a D there. Do you guys see that? Kind of how it like yelled at me because it didn't map correctly. That's a good example of that. So let's restart that. Cool, so it's going to start it up. It should splash a page.
So in that context, will it have all of our trails now in it?
Yes, exactly. So I pulled back a list of trails and it stored it in a variable called myTrails through my context, right? Because I called on the .trails DB set within context, right? And then I printed it out, and in my trails, you can see that it's a list. I have a count of 4 trail objects, and each of them should just be whatever is represented in my database here. Cool. So, how do we use Entity Framework then? So, Entity Framework, what it allows us to do is very easily, besides all of the hiding our DB connection string and making that secure, that kind of made this configuration process a little bit trickier. But if we weren't worried about that, then setting up EF core, like all it takes is like loading up that dependency and you have it. All you need to do is create a context file, right? So how do we actually query our database using EF core then? What we need to do is use it in conjunction with link. So where we were using SQL to query from our data sets within our database before, now we're using EFCore to bring back those entire data sets and query from that data set using link locally. Does that make sense? So, what? Yeah, exactly. So now you can kind of see, like, if those light bulbs are going off in your head, kind of the trade-offs between different ORMs, right? This is super easy to use. It was adopted super quickly. So most everyone uses EF Core. I mean, you're trading off like minimal time, but again, if you're querying for massive amounts of data with a lot of different joins, like for example in like a Stack Exchange website, then that causes some problems, which is why those people created Dapper, right?
It's like if you had, a million items in your database, you just went and pulled a whole million items out of your database for no good reason.
You're exactly right.
If you had a million trails, you just went and queried all 1 million trails and dumped them into my trails right now.
You're exactly right.
Why does an entity have an option to limit what you bring back?
Because that's not really what Entity does. Like this is kind of how this is the differences between ORMs that really exist out there, right? So you're trading off certain aspects of speed, ease of use, like memory efficiency, speed efficiency. I mean, what you could do is you could bring back DB sets and like cache them, so you don't have to continue to make queries to your database over and over again. So in that case, like you could save time there. But that's just how Entity Framework works, which is why Dapper was invented. Does that make sense? Like if Entity Framework could do something like that, Dapper would never exist, and Entity Framework would be just the standard across .NET Core MVC, right? That would be great. So let's say that I just want a trail with ID 5. How would I do that? In SQL, or using Dapper using SQL, or using your DB connector using SQL, we could have done select all from trails where trail.id equals 5, right? But we're not writing SQL right now. We're using EF Core, so how would I write that using link? I've brought back all my trails. So what I should do is, anyone remember how to use link?
No.
Does this one look familiar?
Hey, cool.
Dot where?
Oh, yeah.
Pretty sure you're gonna have to spoon feed us on this one.
Where? What goes in this? Where?
X, rocket, X.
What is that? What do you? A lambda function, right? Yeah. So you said X. I don't like that very much because I don't know what X means. Maybe like trail.
Sure.
Yeah. Let's name our variables a little bit more semantically.
Trail dot trail ID or whatever you have for your ID. I'm not sure what your database has for its ID.
Trail ID. And it's nice because your IntelliSense will pick up all of the different attributes. It has trail ID, trail length, longitude, latitude, name.
Nice.
We have trail ID right here. Equals 5.
Equals, whatever your thing is, right?
Cannot implicitly convert
Whatever
type.
Your route
Oh.
ID that you'd be passing.
There we go.
Your route parameter that you'd be passing in.
And then dot single, because you only want for one, right? Or is it dot
Oh, yeah.
Single or default.
Good call.
And then you're done.
Cool. All right, guys. Nice. Very nice. So this is essentially what's going to replace SQL for us, these Lambda functions, right? So if I were to...
You don't have to do worry. It's single or default. It's just where.
You're absolutely right.
Oh, really?
Jeez.
Oh, slick.
There is a slight... There are instances where that won't work, and I'm forgetting when. But yeah, in this case, you're absolutely right. So let's console.log my trail and see if we got that object back.
I thought you only had 4 trails.
I think their IDs were like 4, 5, 6, 7.
You might have deleted.
Yeah, I deleted a few in the beginning. Cool. So I have my trail, the object of my trail, and ID 5 should be rattlesnake. So cool. There's rattlesnake. Cool. So cool. That's the basics of how to connect your application to EF. Obviously, very easy to use. The only thing that you guys might need like to kind of like brush the rust off a little bit is your link lambdas. But if you guys know like your dot singular default methods, if you guys know your dot wheres, your dot order by, those kind of very simple like top 10 link queries to know, then you guys pretty much are set for whatever you need to query from your database.
What about one to many?
What about one-to-manys?
Like if we have like a trail, a user in Trails, right?
So if that's the case, absolutely. So what we might want to do in that case, and we'll get again. This was more of like actually, I'm gonna turn the video off now.
Okay.
Bye, everybody.